different frequency bands were different, and different kinds of problem statements were there. So overall, I will say that I have not guided them, rather I have learned from their work. Okay? So as I have said, the for a teacher, the learning curve is lifelong. And what experience I could get during the coordination of, say, Center of Excellence of Combated System, in which we develop some prototype. So that time, few of my MTech students and PhD students, they again contributed to some product development and all during that, or some PhD research statements or companies and all. During that, whatever experience I got, that today I am sharing. So overall, that journey I will be sharing. There will be many slides uh, which I would be skipping because in such short stipulated period of time, there is no point in going into mathematical aspect of it and derivation and all those aspects. Basically, we must first get the gist, interest, passion for it, and then should see an overview and then should understand what are the aspects of it. So what happens is different kinds of applications you take, and for that you design antenna, and certain issues or challenges they crop up. And at many places, I would be taking how we found a remedy on it. So my notion is not that what we did is the only way and the best way of doing it. Okay? But I could present that yes, by doing that our problem got solved. Okay? This was there. And from that you can understand something. So a few case studies directly I will be taking for the discussion. So I will skip all the theory part. Somewhere the reference is required. Then I will cover that theory part. But if I try to explain you what is an antenna and what are the important parameters and their measurements aspects and merit figures and all, then this session is also insufficient. Okay, so right now, since very focused thematic area has been chosen, some things I am assuming that at least that much part is known to all. But not knowing is not a sin. पाप नहीं है वो. Okay, so in that case, if someone is missing the link and is not understanding, straight away raise the hand. Okay, because I am not a Baba here who is giving discourse and आप भक्ति भाव से सुन रहे हैं मंत्र मोड, तो उसके लिए नहीं है. The interaction will be better. ठीक है, then I will also understand that where I am progressing and all, and what my content delivery is making an impact or not. So feel free to talk. This is completely formally informal. ठीक है, technical session. So wherever things are there, you have a query, you can interrupt me and can tell me. So with the available time, I will try to give the best possible justice to best of my capabilities. Before I go formally for the content and all, as you know, many of you have seen our department already. Professor Morelkar is a student of VNIT, or Anand keeps on coming and all. In conference also, a few of you have joined us and all. So this is our department, which is epicenter of our different activities which keep on going there. So Department of EC in VNIT, and as far as various advanced level or center of excellence level its activities are concerned, then I will just in brief throw some light on various activities which the information may be useful for you, and then I will shift to the topic. So you will find that, as it was said, under TechWheel subcomponent of 1.2.1, from 2013 to 2022, 9 crores or 90 million grant was received, in which particularly this Center of Excellence of Combated System. Combated system is a term coined by us only, which is hybridization of communication and embedded. So worth of around 4 crores of equipments, various kinds of test instruments, high frequency sources and test instruments are available for validation, prototyping and product checking, design and all, along with the necessary software tools for the field of amalgamation of communication and embedded system together. So mobile is best example of that. So mobile is a device in which embedded and communication both are there. So that kind of theme is there, then this lab is there. We have recently established the Center of Excellence in Electromagnetic Compliance and Electromagnetic Interference EMC-EMI, and we have CISPR and mill standard 19 possible tests with an anechoic chamber of 30 megahertz to 40 gigahertz frequency range or sweep, and size is 30 feet by 17.5 by 14.5 tall. Right now, we can boast that the anechoic chamber which we have is even bigger than what IIT Bombay has, and the frequency range is also very good since recently established. But it is fully pre-compliance test setup right now which we have. And the main purpose is the academician or researchers who are working in this area, they can come do the testing and all. And the industry people also are working on various products, even like this also. It has to have EMC-MI compliance before it comes to the market. So during design time only they can do the pre-testing of the product in our lab setup and then can go to ERT or Samir and all for the final certificate. Then government of India has established 100 use case 5G labs all over India. Department of EC is one of them in VNIT. So for this region, this is there. Please keep in mind that this facility is not exclusively for VIT. It has been given by the government to cater this region. Okay? So any one of you, as a teacher, entrepreneur, whatever is there, then has some a good idea, business idea as well as technological development idea based on 5G and all in any field, smart agriculture, automation, healthcare, whatever, or education through ICT and all, they can come to us. So actual base station of the mobile has been given, the controlling software, control plane of mobile, this thing has been given. Even if your research requires a license frequency band, then temporarily the license of that frequency is also provided. So DOT is taking care of that. We have drones, we have sensor arrays, we have AR, VR components, and also all these fields connected with 5G. If you want to work, then you can visit this lab. Then we have Center of Excellence of AI/ML, again established by MIT. So there are high-end and computing machines and all for AI/ML this thing. As we also run online MTech program for working professionals in applied AI and applied AI communication. So these kind of labs have remote access also. Then Ivy Labs, then Space Technology Incubation Center by ISRO. Then we are Vishram Zamdar Siemens Center of Excellence, as many of you might be knowing. And Center of VLSI and Nanotechnology is the associated department again or center is there. So this is the entire scenario, different labs and centers which we have, with which EC works, and we have strong faculty group related to these thematic areas. So this photograph, if you find, is the best mobile station given by DOT in use 5G case lab. This is the tensile or anechoic chamber picture and other test setups, particularly as far as the EMC-MI lab is concerned. And this is picture of our 5G lab, particularly and some products which were developed and all. Now, this is also there. Many of you, if you still have not done your PhD, may think that doing VNIT PhD means GATE is compulsory, but for your kind information, the non-GATE category is also there. And looking at the small ad itself in the newspaper, people avoid to go to the website and reading other things and all. The first thing they think is that it will be very difficult to do PhD from there. But they should not think like that actually. And if they really want quality work and all, they must approach. So part-time, full-time internship opportunities, JRF, SRF, and whenever that ad comes or call comes, you can go through it. There are 10 different categories of admissions under which you people can come and join PhD program and all, or can propagate this information. As far as courses are concerned, we give one UG course, BTech, of which the entry is through JEE Mains. MTech in Communication System Engineering, there also first gate admissions are done, and then if the seats are still vacant, then they go to the non-gate students. There are skill enhancement courses which are run under Center of Excellence of Embedded Systems for everyone, teacher, entrepreneurs, whatever is there. So these courses are 30 hours courses usually. and there you can learn all the advanced tools and hardware software setup which is available in the department. And as I have said, online MTech program very suitable for working professionals. So far, three cohorts have been admitted, and more than 300 students right now are registered to this. So this is scenario. This is available on the website. What courses we take through COE now. So I will start formal with my topic now. As I have said that application specific antennas when are designed. Before I progress further. So the intent to show all this information related to department and activity was to attract people for any kind of fruitful collaborations. You can come join. So joint paper publications, or you want to pursue research, or you want your students to have further extra special guidance for BTech projects and all. Any such kind of intent is there, you guys are always welcome to the department, and anytime you can approach us. So going further with formal my topic, this thing. So you will find that various application specific antennas when are designed, the general challenges which we face, we will see first one by one and how they are dealt with and all. And these challenges will have what kind of repercussions on the design methodology or strategy that we will have to see. So first thing, nowadays the biggest challenge which we face is nothing but performance needs to be wideband or ultra wideband as far as antenna design is concerned. In my first part or the majority part, I will by default will be talking about antennas only. Then we will go to other RF component or passive RF and all. Okay. Why so? Because you have kept lecture of Dr. Gandhi, you would be putting lot of focus on the active RF designs and all. Then you have lecture by Dr. Arvind also from our department. So there would be lot of other microwave active passive component MMIC design focus also. So that's why I am skipping that so that you can have entire variety of discussions as far as this thing is concerned. So you will find that ultra wideband or wideband. Now, if you see the theoretical definition of antenna itself, it is a transducer basically. So antenna is a transducer, and majority of equipments like antenna which deal with electromagnetic field, they inherently are narrowband devices. Okay, so you will find that the resonance frequency, this concept if we see like LC circuit basically is there, and we see that at one particular frequency it gives the maximum outcome or maximum output and all. An antenna is nothing but an LC circuit. Okay, so it is basically a resonant circuit, it is a transducer, and inherently it is a narrowband device. Okay. So theoretically or ideally it is not expected to give resonance at multiple frequencies. Okay. But now what we are saying that no, my application demands that the antenna should work on multiple frequencies. Okay, that means now you are not talking about a single frequency, but you are talking about a band. And that band also you are asking to be wider or even ultra wider. Okay. So when high range of frequencies come in picture, there would be a frequency sweep in the operation. Okay. And retaining or maintaining a stable bandwidth over such a large range of frequency would be very difficult. Okay. Why is it so? Because any frequency sensitive devices, they would always fragile and would not be steady in their working when frequency shifts from one to another. Okay, this is the case. Now, if simply an LC tag circuit, if we consider, okay, how would I bring the variation in frequency as far as circuit is concerned? So I know that 1 upon 2 pi under root of LC is the basic formula which we all know. So from here, varying pi is of no use, it's a constant. Whatever we can vary is nothing but what, either L or C. And practically, what we will do, whether we will vary inductance or capacitance, okay, out of the two, which is practically more convenient to vary. So in this case, you will always find that varying capacitance is easier or inductor. Okay, what we do practically. Okay, it is always capacitor. Trimmer, pedal, if you see the size is small. Have you seen the variable inductor anywhere? Okay, anywhere variable inductor. So in first year lab we give thermostat, how bulky it is to give a variation in that. So basically you will find that variation of capacitance would be easier. Now through varactor diode also we can have that variation and can have or achieve tuning on different frequencies and all. That is what you do in remote. Okay. So antenna when wider band or ultra wide band is designed, then if its electrical equivalent is found, then whatever assembly you are creating, okay, or type of antenna you are creating, you have to see that its capacitance should get varied at different frequency and multiple resonance should be achieved. Okay. So in theory, if you have learned transmission line also, then you have seen that open-ended transmission lines can be converted into wired antennas and all. They can be center fed also. But then matching is to be achieved, and then the maximum power transfer theorem must be obeyed, so that the outcome will be fully transferred to the antenna and all, and there would be faithful radiation, and complete electrical signal will get converted into what the waves and all. This with all expected efficiency, if to happen, then you will have to work hard on it to achieve a wide band stability. Okay, if application is like that. Now, one simple example I will give, that ferrite core antenna you can design as our preside in there in his presidal this thing speech he was talking about ferrite core antenna based and all. So FM base, if you want to design one wired antenna would be sufficient. But for a band, if you want to work it 88 to 108 megahertz, then it's a band. And so many radio stations are to be received. So at each radio station frequency, you must have a resonance. Then only it is there. So first challenge is when antenna comes in picture, the second side of the coin is frequency. Okay? So if you tell anyone that I am working in antenna, then immediately the person on the other end would ask which frequency band you work. Okay? So there are people whose entire life is spent that they have not crossed 1 gigahertz and have worked in megahertz only sub 1 gigahertz frequency band. Okay, reason behind it is because they were working on naval communication or those kind of applications only, or microwave link to link or other kinds of projects. Okay, but if other persons are in space related communication or this, then they will talk about X band, K band, KU band, and all on higher range of frequencies like that. It is there. So it is very rare to be seen that a core antenna person working on all frequency ranges and all types of antennas. It is not possible. Okay? That's why main challenge is to make it to work for a wider range of frequencies or ultra wideband and how to achieve it. Okay? Then continuously evolving high frequency spectrum and applications. Okay? How fast like 2G phones were converted to 3G, how fast 3G became absolute and we got converted to what 4G, like that it is there. And even now 4G on the verge of extinction has gone and we are talking about what 5G implementation and all. So even right now if you go to market and try to buy a mobile phone, you will be buying it which would be compliant with the forthcoming technology. Now every generation when comes, what change basically is happening. Now, in a layman understandable terms, they are telling that we are changing the frequency band. Okay? And then because of that, the other repercussions are the data rate change and other things are there. Multifunctional capacities or kind of modulations used or multiplexing techniques for transmission and all would also change. So the technology never stabilizes. That means in antenna by hard work, you come to some conclusion and design something, the next challenge again stands. Okay, so for 4G, if you have worked out a planar inverted F antenna, then they will say that no, 5G we are going for this frequency band now, and there would be short range, this thing, smaller cells communication also, or near RF connectivity is also required. Now this is very difficult. Okay. So this is another challenge that frequencies are going higher. Now higher frequency, another challenge. In general, in antenna or microwave components and all, the design aspects, dimensions, parameters are directly in proportion to wavelength. As you go higher in frequency, wavelength will reduce. It it reduces when when you start talking about gigahertz and all, it will even go below millimeter. Okay, and therefore, if you say that now I want a circulator with some this thing, and at end I want for Bluetooth, low energy Bluetooth connecting antenna for a module or something like that. And if you calculate and try to do this, the physical dimensions would come to a range where you cannot see it also, where it is. Okay, now it's fabrication, okay, its placement, connectivity, characterization, measurement, everything is problematic. Okay, so what is happening is as the frequencies are going higher, physically really implementable antennas are also getting converted to ICs now within it. Okay, so that is how we call it as IMMIC design basically. Okay, so such a challenge is when is there because the spectrum is trying to explore with higher range of frequencies and all, and continuously the applications are also changing. Okay. Now, application wise, we will see what kind of challenges it will have. But one I can mention that if you have any antenna is related to wearable gadgets, say mobile, smartwatch, many of you use. Nowadays that craze is there that it counts step and tells you the BP also or pulse rate or whatever it is there. But when it is wearable, that means it has to adhere to the stringent standards which are prescribed by all international organizations and all. Starting from World Health Organization, WHO. Okay, so there is specific value of specific absorption ratio. Okay, SAR you cannot cross. Okay, so that thing is there, or you can find that there are other aspects also, EMCMI compliance, and so many things are there. So you will find that when such type of things are there, it becomes very challenging. Second is antenna can be a bottleneck to completely what I can say block the speed of communication. Okay, so if I ask you, is your mobile an analog device? The answer should be. Is mobile an analog device? The answer should be yes, very much. Okay, so you will find that 60% of the working of the mobile is in analog domain only. Okay, in RF and everywhere. Okay. If I ask you, is your mobile a digital device? Again, the answer should be yes, DSP, digital signal processing, real time. Okay. Then again, if I ask, okay, then is mobile a RF device? The answer is again yes. Is mobile a microwave device? Again, the answer is yes. So you will find that one device, but it has so many verticals, compartmentalization. Okay. Now, in this case, we use mobile phone, but there are so many funny things about it. How many antennas do you think your smartphone has? Okay, those who work in field, they know it, but those who don't, answer from them would be interesting. So as a user, we use it, but how many of you know how many antennas could be there, or your guess and not you, madam, you are the coordinator. So this thing. So in general, any guess from others like three, four, or only one? When I am talking about ultra wideband or wideband, okay, different frequencies are there. Okay. Two, one, three. See, different answers are coming. Now, most of you are related to electronics and all, and that I tell students that certain things which we must know. Okay, whether you work in antenna or not. Okay. So, I am very much sure if I ask the question other way that how many megapixel camera your mobile has. Okay, 90% would be able to answer it because they have bought the phone on that parameter only. Okay, or battery life and all. But now the current scenario is even a commerce graduate can be very studious and learn about the technology and all. And therefore, as a user from the field, we must know certain basic things like how many antenna it has, which IEEE protocol it complies to, whether you are a teacher of circuits or networks or communication. But these things must be known. Okay. So when we are driving a two-wheeler, the mechanic cannot fool us, even though we are not automotive or mechanical engineer, but still we know whether he is overcharging or undercharging or whatever is there. So is he fooling us if he says that no, carburetor has this problem, I will charge. Nowadays carburetor don't come at all, but anyway, 1,000 rupees, 2,000, we say no, it's not like that. Don't tell me anything. We generally answer like that. Why? Because certain information, basic information is always with us. Now you will find that your antenna, or sorry, your mobile phone cannot have just one antenna, because as I have said already that antenna means it is always frequency sensitive, and your mobile phone is not just limited to one functionality of making a call or receiving the call. It is beyond that. Okay. So how many functionalities? Now we know GSM technology it is using, and GSM itself has approved two bands of frequencies. One general up to 900 megahertz also, and another is 1800 or 1.8 gigahertz band, particularly plus minus. So it should become compliant with US, Europe, or Asia, Pacific region and all. So two GSM bands worldwide are used. That means if your mobile phone manufactured by certain companies to be used anywhere where it is delivered, it has to have the electronics related to both these frequency band, so 800, 900 megahertz as well as 1800 megahertz. Okay, and naturally for these two frequency ranges, the antenna cannot be common. Therefore, the GSM one antenna, GSM two antenna, two band. दो तो यही हो गए पहले basic. Now is your antenna, sorry, mobile using that? Can you listen to FM radio? Okay, so 88 to 108 megahertz. This is something else frequency now. We were talking about 800 then 1.8 gigahertz, and now here we are talking about 88 to 108 megahertz. Again, something different frequency. So again, one antenna would be for the FM band. Okay, third over. Okay, then with your mobile, the biggest functionality or largest which you keep on using, without that you can't even breathe. The first thing which you see is whether Wi-Fi is there or not. Okay. So does it get connected to the router? Now that communication based on which IEEE protocol? Okay. So it is 802.11a, b, these three standards are there. Based on if the tail-end frequency bands if are studied which are allotted to it and all, then we would see that okay, there is this 5.8 gigahertz frequency band is also there, and 2.4 is also there, which is ISM based and all. Means two bands when I have given. Okay, if you simply install the Reliance Jio router at your home, it will show two distinct channels are available. Because so Geo 5 and Geo 2, 2.4 or 5. That means through both, if your mobile is able to get connected, that means there are for Wi-Fi connectivity two antennas are there. So far we counted 3 plus 2, now has gone to 5. Okay. Anything now, does your mobile has a Bluetooth connectivity? Okay. That is also good. Again 2.4 subset subband, which is again ISM distinct for connectivity. So for Bluetooth, one antenna would be there. Okay, so 6 यही हो गए. And near frequency communication yet is not activated in India, but in mobile it is there. Like we say touch cards are there, like that you simply just take the mobile near to the device, something will happen. So that communication band is again different. So 7, 6 functionalities we have found. Now is it happening that when you are listening to FM radio, you can't receive a call? Is it like that? No. That means these functionalities are simultaneous and independent. So what? All antennas are needed. Okay. Now all antennas are either transmitting bodies or receiving bodies, and 6 antennas in such a slick device you are accommodating. Okay. And all of them are LC tube circuits basically. Okay. So if I keep them in near vicinity, immediately what will happen? Okay. So that interference in other way we call it as what? There would be strong mutual coupling between them. Okay. Now mutual coupling is always advantageous or disadvantageous? Okay. Mutual coupling is advantageous or disadvantageous? Huh? We will always say disadvantageous. That is 100% wrong. Okay. Why? It is subjective. It depends. What is the purpose? If I am teaching you the transformer and if I ask you mutual coupling is advantageous or disadvantageous, now the reference might change. A transformer entire working is based on what mutual. If it is not there, it won't work. Okay, so it is subjective. But in case of communication devices, when multiple antennas work in a very sleek body, the chances are there is lot of interference because of mutual coupling. Okay, and you must have seen the KVL matrices which we usually write in network theory and all. So that those questions you try to recollect where we draw an inductive coil. Two coils are there, so we draw some circle, circle, triangle, triangle, showing that whether the current going or coming direction is same or not. So off diagonal elements are what? Mutual elements. So it will be self plus mutual inductance. Okay, that means an inductor cannot just think about itself. Okay, along with that, there would be a factor if other three coils are there. Okay, related to that, whether there is contribution or deduction from the inductance or that interference is there. Just now, few moments back, I told you that antennas are nothing but LC circuits only. Okay. Now, if 6 and 7 antennas in vicinity of each other in one sleek body at frequency range from starting from hundreds of megahertz to gigahertz, if they are working, just imagine what kind of mutual coupling they will be having, which is very disruptive and disadvantageous because all the functionalities are simultaneous. As we have said that no, all of them are equal. Okay. Therefore, avoiding mutual coupling base or bringing it to the negligible level, that is the research challenge for the designers who have designed antennas for this particular mobile. So earlier wired stick type of antennas were there. So mobile used to have this kind of stick which your router has. But now we don't even know. That means what they have been flushed or merged in the surfaces itself. Okay, so that means what the technology has moved towards use of planar antennas now. Okay, and such six planar antennas which are in near vicinity to each other, if they are working, avoiding mutual coupling or interference is very difficult. Okay, so you will find that this entirely affects the data rate. Okay, so you might say that I have come up with a new VLSI technology. My chip can process the data real time very fast. Now, why such real time restrictions are there? You will be surprised. For example, how many of you teach DSP, digital signal processing in lab? So you must be taking practicals of convolutions also. Okay. How many segment length you usually take? Huh? 7, 8 samples, isn't it? Now, to what frequency human speech is limited, band limited? When we speak, usually, so what is the frequency? 20 kilohertz, 20 hertz to 20 kilohertz. ये सुनने का बैंड है, मैं बोल रहा हूँ स्पीच का फ्रीक्वेंसी क्या है? ठीक है, ह्यूमन बीइंग आर नॉट अल्ट्रा वाइड बैंड, 20 हर्ट्ज टू 20 किलो हर्ट्ज ये थ्योरेटिकल सुनने का बैंड, ऑडिटरी. ठीक है, आई एम सेइंग ह्यूमन स्पीच which will generate from the vocal cavity may be female, male, but it is band limited to what frequency? It is centered around what? Huh? Yes, so it is actually around 3.4 or something like that. From there, different format starts, and that is how the male and female voice gets identified and all. But let's say 3.4 kilohertz. Now, if 3.4 kilohertz around that it is centered, then all of us know that Nyquist rate of sampling minimum required would be how much? So 6.8 kilohertz. Okay, so the standard telephony or PCM listing standards, even if we consider the sampling rate with all interleaving frames and all is 8 kilohertz for the speech. Any speech basically in a standardized way is sampled at a rate of 8 kilohertz. Now, when I am saying 8 kilohertz, that means in 1 second, how many samples we have generated? When I am saying that the speech is sampled at 8 kilohertz, that means 1 second, in 1 second, I have created how many samples? How many? 8,000. 8K is the sampling. Okay, now if I allow you to speak only for 1 second, what will you speak? Only 1 second. 1 second you should speak. So you will only say what a letter A, B, or hi. Okay. That means even if I just say hi, okay, and if my voice is getting sampled, how many samples I will create? 8,000. Mobile पे तो आप कितनी बातें करते हैं? ठीक है. So when real time your device is processing that now, क्यों सब बैंड कोडिंग करना है, लो बैंडविड्थ में लाना है उसको ट्रांसमिशन के लिए. So when it is digitally signal processing, it real time convolution will start. ये background noise remove करना है, सब करना है, like that it is there. So DSP chip now taking blocks of your speech sample and then processing it real time for convolution. तो 1 सेकंड का भी रिकॉर्डिंग अगर आपको प्रोसेस करना है तो ब्लॉक लेंथ कितनी रहेगी? 8,000. हम बच्चों को प्रैक्टिकल में कितना देते हैं? 8 या 10. That's why students say कि इंडस्ट्री को जो रिक्वायर्ड है वो टीचर्स पढ़ाते नहीं. कोर कंपनी में जाएंगे कैसे? उनको पता ही नहीं है कि रियल टाइम कैसा इंप्लीमेंट है. ठीक है. सो TMS 320 किट भी है. ठीक है. MATLAB भी है. नाउ इज MATLAB सो वीक दैट इट कैन नॉट प्रोसेस बियॉन्ड 8,000 के. आप उसको 8 लाख बोलो तो क्यों करें? ठीक है. सो योर एक्सपेरिमेंट इन द DSP लैब शुड बी bring a 300 rupees mic, connect it to the computer, ask the student record your own voice, remove the background noise of fan by doing linear convolution real time and play again your recorded audio. ये एक ही एक्सपेरिमेंट अगर आप कराओगे तो पूरा DSP एक झटके में समझ, because that is the first thing which the Qualcomm company or any other core company will ask them to do on the first day itself, and the student will be happy. ये क्या है? कभी then they will start finding internet, Python code and all. So teachers have to enhance the depth in lab. You cannot give excuse that we are affiliated to university and this and that. MATLAB is a giant elephant. Okay, it can do anything. We are restricting ourselves. And then in that case, so convolution का coding कितना बनता है? 3 या 7 लाइन का रहता है, because all ready-made functions are used, something some bar graph comes and all. Okay, goody functions. ठीक है. And 19 out of 20. So not deviating again, but this thing. Now why I am referring this? So just imagine if this is at real time, it is to be processed. Adaptive subband coding, if it is implemented, which is there in your mobile phone, and so many multiplexing of users are there at the upper layer itself, then you just imagine what kind of data rate would be required, because there should not be any latency. Okay, otherwise there will be halt. If I am saying hello, the other person is listening it after 2 seconds because electronic is processing. Okay, so just imagine what will be the data rate. And now you are greedy. Netflix जहाँ है movie पूरी आनी चाहिए download. 5G means. So now China is saying that we have gone to quantum communication and you can download 1 GB in 1 second. Sorry, 100 GB in 1 second. Or 1 terabyte data also they are downloading in few seconds. So they are saying thousands of movies in 1 second you can download. Okay, if this kind of demand of data rate is there, that's why I have given the DSP background. You will say that कि sir तो antenna भूल गए कुछ और ही बता रहे, but first myth is all subjects are interconnected to each other. Okay, and without its background we cannot progress anywhere. So first you take this out that I teach devices so I can never work in antenna. ऐसा बिल्कुल नहीं, बल्कि ज़्यादा अच्छे से काम कर पाओगे अगर devices का background है. ठीक है, so that's why high data and speed of communication. Now what has happened? I have created the circuit, chip is there, RF part is there, amplification is there, but finally when it comes to transmission, I have connected an antenna which is narrowband based, doesn't support this band. Okay, your entire band of the communication or data rate would get restricted. Okay, so to achieve high speed is very important nowadays, and therefore the space diversity based techniques like MIMO and all has come. So if MIMO is a technology which is at implementable level, you will say that enhances my data rate, but अरे antenna तो वैसे डिजाइन करने पड़ेंगे. Otherwise आपने इतना बड़ा पाइप से वाटर लाया पूरा, but then वहाँ पे नल इतना छोटा लगा. What is this? Okay, so antenna is basically the connecting end at the last point itself for transmission and reception, and therefore it will block your entire data transmission capacity. Interference I have already covered. Now interference of two types. If we stuff six antennas in mobile, तो म्यूचुअल कपलिंग से तो वहाँ जो मिटिगेट करना पड़ेगा इंटरफेरेंस, दैट वन इज देयर. अनदर इज देयर आर सो मेनी मोबाइल. So as a device, it is vulnerable to the susceptible radio frequencies which are already present in the environment. Okay, so all kinds of interference are to be avoided as per as working of this particular antenna or this thing is concerned. Okay, some applications of frequency selective surfaces when we will discuss, we will see that the purpose changes completely. Okay, if I am right now also I can mention now that word is very much buzz is going on, intelligent reflecting surface or reconfigurable intelligent surface and all. So they are saying that establishing mobile stations is a very costly technology. So we should use resources, all these buildings and all. So their facades should be used. Okay, so a new technology has come. You see that those swanky buildings are there in IT park, they put glass and all. Okay. Instead of that, a new material has come, which is nothing but a solar panel. Okay, that means both you do at a time. You do the beautification of building also, and at the same time it is power generation also. Okay, so the idea is why not to put a surface like this, which is frequency sensitive. Okay, so the last mile connectivity is obtained. What is happening is when we are driving, if we take a right turn, suddenly call gets dropped. That means there cannot be a coverage. How can I enhance the coverage? Okay, so there if there some hospital building is there, its facade will help me to have additional strength of the signal reflected from it. Now, but when it is additionally reflecting and trying to provide me the signal, it has to be designed as per the application of frequencies. If we if it gives me unwanted frequencies, it's of no use. Okay, so it has to be reconfigurable and programmable. So there can be active components also in it. There can be pin diodes and all which are doing the RF switching and making it sensitive to different frequency. Entire circuit. Okay, so whichever frequency is there coming over there, it should be able to give me. So vehicle to vehicle, V2X communication or any other mobile coverage or further generation mobile or wireless communication will solely be dependent on these factors or aspects. Okay? Now same surface, same technology, but now I will be using it on the surface of the defense aeroplane. Okay, and now I want stealth technology. Now what I want, my aeroplane should not be detected by the enemy radar. उल्टा हो गया ना. अभी क्या चाहिए था आपको, जो भी फ्रीक्वेंसी आए वो बिल्कुल मिलनी चाहिए. और अभी क्या चाहिए, जो भी फ्रीक्वेंसी इस पे पड़ेगी रिफ्लेक्शन होना ही नहीं. Functionality got changed. Now, surface is set. FSS, frequency sensitive only. Ain't but application got changed. That's why challenges because of application. Your purpose gets changed. Now, enemy radar means pulsating signal. It will say, will receive from it. It will calculate the distance and can easily locate where the plane is. So your surface must be sure enough that it becomes transparent to those signals. Okay, but at the same time navigation control कहाँ से रहेगा, अपने कंट्री से. तो अपने कंट्री के ATC से तो कनेक्टेड चाहिए कि नहीं चाहिए. Okay, that means when our frequencies are there, the plane should respond, and at the same time when the frequencies by enemy are there, it should not respond or reflect. At a time, these two complications are to be handled. This kind of complication is there in the application itself, and therefore you will find that in such application, your interference plays a very important role. जो 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 चर्च सिग्नल्स आपको मिल रहे हैं वो आपको पता ही नहीं है कि ये एलईडी के है या कोई दूसरा इंटरफेरेंस. So that classification, identification, detection, suppression, absorption, so many things are there which your antenna should be able to handle. Then compact design, who will buy mobile which is very bulky and bigger in size? We will go for smaller, thicker, foldable, these, that, so many things are there. Okay, so you will find that compact design is another this thing, because then, for example, The naval communication then comes in picture. In salty water, your lower range frequencies are effective. You cannot go for the gigahertz range. Okay, marine communication, navigational this thing, related to submarine and all. And there you will find that as you come to the lower application, wavelength will increase. So certain range frequencies you will find that the antenna length can be 800 meters. Okay. Now for transmission we can erect a tower. Okay. But for a submarine कहाँ लेके जाए वो 800 मीटर का antenna? Okay, that means what? You will have to create a wired antenna and you will have to embed it as a loop or whirl in the body itself multiple times. Okay, you cannot leave it as a tail also. तो इधर उधर कहीं अटक के टूट जाएगा 2 मिनट. So it is very challenging. That's why what size compactness, physical application, frequency आप change नहीं कर सकते. Dimension यही रहेगा and at the same time in small size you have to accumulate. So this one particular thing. Okay, then complexity of geometry and shapes. Okay, most of the antennas like challenges which we work and all we say अच्छा क्या material use किया they say FR4 ठीक है FR4 use किया. FR4 is generally a material which is like used for PCB and all that thing is there. Now ये आपका FR4 का base antenna जो है if suppose it is to be embedded on the radar of the missile because that antenna is to be used for communication, okay, और for GPS के जो coordinates मिलेंगे सैटेलाइट से उसको प्रोसेस करना. मिसाइल ऑटो गाइड होगी तो कहीं तो भी तो कनेक्टेड रहेगी ना जहां से उसको डाटा आएगी. ठीक है, सो दिस एंटीना यू विल हैव टू कीप. आप मिसाइल का पूरा शेप आप आंखों के सामने ना लीजिए. इट इज वेरी स्मूथ. ठीक है, कहीं पे भी ऐसे प्रोजेक्टेड आपको दिखेगा ऐसा डंडी का एंटीना उसके ऊपर लगा उसकी मूवमेंट ही रेस्ट्रिक्ट करेगा वो. ठीक है, एंड एरोडायनामिक पूरे बिगड़ जाएंगे because it has to travel with a speed as a rocket or something like that. So that shape restriction is there. That means what now for missile whatever antenna I have to design, mobile में ऐसा चलेगा कड़क planar, but missile में ऐसा लगे conform. Now you have to bend because my outer surface is what circular. So radar-based design is where I have to inside it I am going to paste it and place it inside the surface like what I am doing in mobile. Then the substrate has to be conformal. Even it can be antenna array, phased array antenna resistor, working for that entire band and giving the communication capability. Now if you are using a material which cannot be bent at all, then purpose कितना भी अच्छा हो resonance तो कुछ भी हो. ठीक है, सेकेंडली मिसाइल जब चलेगी तो टेम्परेचर किस रेंज में हो जाए. ठीक है, वहां जाके वो पिघली गई. सो व्हाट काइंड ऑफ मटेरियल यू आर यूजिंग, व्हाट आर इट्स डायनामिक्स, शेप रेस्ट्रिक्शंस क्या है, लाइक दैट सो मेनी challenges would be there for forming a conformal array or this. And last but not least the major challenge is adherence to the standard. Now this is very important. Okay, so in this case, what has happened? You are designing a smartwatch, and finally, smartwatch can it be connected or linked to your mobile phone? Yes. Okay, means on your body itself the network is there. There is one transmitter and another receiver. Okay, so this is body area network now, wearable. Now you have designed some antenna which has a very good gain, radiation pattern, directivity, everything is there. But problem is to use that antenna, you have to feed larger power to its support. Okay, more than 1 watt, 2 watt like that it is there, which should have been in milliwatt and all. If you are doing that, what will happen? You are using or handling power for radiation which is beyond the prescribed value of World Health Organization SAR values. Okay, and then your antenna, your device or that watch itself will cross the EMC/MI compliance. It would be a spurious radiating body out of which the radiations are coming, which will be harmful for the human tissues, muscles, whatever. ठीक है, तो वहाँ restriction है, आपको पहले ही बता दिया गया है कि per kg, ठीक है, 0.98 और 1.2 हद हो गई तो that particular watt milliwatt के ऊपर आप नहीं जा सकते. That means what? When antenna is to be designed, okay, if you want to make it a successful product, then it must adhere to the standard. आप अपने मन का कुछ भी डिजाइन नहीं कर सकते, ठीक है, and standard adherence is very difficult. ठीक है, so most of the innovative technologies or innovations they come from war. Means during war the newer techniques are found and later with their advantages they get converted into public technology. Okay, so CDMA, GSM, all have been they have been innovated for the defense or war purpose. Later, their patents they get decommercialized and open for public and can be used for different kinds of this thing. Okay. Now, when this thing is there, what we can do then? We can go for certain high range of frequency, say millimeter this thing and all, and try to overcome the challenges which are over there. Okay, so definitely you must have understood that if I would have just shown the list in 1 minute and I have gone ahead, okay, you would have noticed, okay, these are the general challenges. But equally, I am giving you the background that what these challenges are, how actually it got posed. Okay, so benefits of millimeter wave antennas means what? So definitely you are going for wider or higher bandwidth, high data rate, size would become compact and all, high resolution and precision can be there. So beam steering can become completely intelligent and you can control the directivity etc. dynamically very nicely. Reduced interference is there, enhanced security is there. But in technology, nothing comes free of cost. It's always a trade-off. What you are doing, you will have to pay a cost for it. First thing is the fabrication itself. Millimeter, कहाँ दूँ? The size is so small that means you will need special tools and equipment. And उसके ऊपर भी problem है measurement कहाँ करूँ? Okay, so right now in VN90, now the anechoic chamber pre-compliance or a VNA up to 40 gigahertz has come. But suppose prior to 6 months this thing back, if some innovator here as a local this thing takes an initiative to design an antenna for 33 gigahertz, where to test? So 6 years back, my own PhD scholar, even that facility was not available in entire India because he was working on 38 gigahertz millimeter wave antenna for concealed threat detection. You will see the case study. Okay, so from where he got ultimately measured or tested his antenna from University of Liverpool, UK. Okay, for that pounds में पहले shipment का खर्चा करना पड़ा, then like that, then this thing. But you have to do PhD है तो करना पड़ेगा. Without measurements कैसे results होंगे? Simulated measured results compare कैसे होंगे? Okay, so that's why we only go in terms of publication. Already he published papers and also he could have easily bypassed the test and submit the thesis and all. But you have to take the work to the complete concluding this thing and that's why such type of efforts are needed to be taken. Okay, and he did that and lot of advantage was there. So you will find that there is always a hidden cost of it. So this kind of advantage you might get, but then in that case there are various kinds of costs or these thing challenges again will get posed. Okay, design challenges specifically when you go to millimeter wave antennas and all what you will have. Okay, advantages you have seen. What challenges would be there? So propagation losses are there. These are very material specific at this particular frequency range. Moment you change the frequency, the waves change their behavior. Okay, completely. So you cannot just assume them or take them granted. Material limitations are there. Thermal management is very challenging. So if you are working for applications like missiles and all, okay, then you need materials which are very what rough or they are highly reliable and all for defense applications, which is usually not that easy to get those. So durate you ask, even one simple this thing, piece, you will get it at a very high cost, or you will have to give explanation why you are buying it and also after certain this thing no one would give. It is just like tomorrow if you say that my experimentation is based on uranium, so ऐसा कौन देगा 1 gram? It is not possible. So many material limitations are there. Then manufacturing precision. So you will have to send it to some good lab and all. So IIT Bombay or Care Center at IIT Delhi might have that 3D printer which can go to that resolution and print your prototype or can get it fabricated and all. Then the difficulty in case of dielectric resonating antenna is further because they are liquid based and all and so much things are. ठीक है, so अब आप इमेजिन करिए जिस एंटीना में लिक्विड है वो उल्टा हो गया तो फिर क्या हो. ठीक है, so the assembly and practical this thing, but then there are optical antennas also. Okay. So you will find that multiple functionalities nowadays are expected from antenna. So probably Dr. Arvind will take. So you can call it as a filter, means filter and antenna together. Rectina means rectifier and antenna together. This is not just transmitting or receiving, but at the same time you will have to do rectification also. And supported by an array of active or passive components together to give that particular functionality. Then its integration with other components. ये तो सबसे प्रॉब्लम है. ठीक है, स्टूडेंट कमेंट दे शो ग्लैडली हो गया सर डिजाइन ये बहुत अच्छा. ठीक है, but moment BNC or SMA connector is connected to it and all, and finally when we connect it to the low noise amplifier and all, the picture is completely different. Now simple. If I draw the block schematic of a transmitter, antenna would come at which stage? Last stage. Okay. And for receiver it will come to what? First stage. Now any electronic circuit basically, what should be the ideal input impedance? Correct? Which will come in picture when it is receiver, because that is the input. Okay? And any this thing electronic circuit, what is the ideal output impedance? Zero. Experiments are there. That will come in picture what? When antenna is connected to the last stage. Okay. So a complete impedance reversal is there. Now, if this kind of thing is there, so we have learned maximum power transfer theorem, complex conjugate. So if your port is offering impedance of A plus J times of X, antenna must give what? A minus J times of X. Nullify the reactive or susceptance component and all. Then only it will become pure resistive and the entire thing will get transferred and all. But then you say that okay, at receiver it is infinity and at transmitter it is zero. So then can I use the same antenna for both purposes? Okay. Can I change like whatever is connected to the transmitter, I will plug it out and will connect it to the receiver, and receiver antenna I will connect it to the transmitter. Now will it work? Will it work? Okay, now sometimes student can ask you this question. This is the case. So there is can something point to point link this is there? Can this thing work? This we must know. Very fundamental. Okay. Now once we know that one is infinite compliant impedance, the impedance to be compliant, and another is zero, the obvious answer is what? No. Okay, but it is wrong. Okay, the 100% correct answer is yes. Why is it so? I told you that antenna is a transducer, and inherent it is a reciprocal transducer. Okay, so many theorems which we learn in network theory, उसका use क्या है? सिर्फ exam में numerical pass करने के लिए. Okay, so antenna is basically a reciprocal device. That means the same antenna which is used for transmission can also do what? Reception. ठीक है, और ये हम भूल जाते हैं कि हम मोबाइल फोन यूज करते हैं. आपको मैंने फ्रीक्वेंसी बैंड वाइज फॉर डिफरेंट फंक्शनलिटीज हैव टोल्ड यू दैट डिफरेंट एंटीनास आर देयर, but I have not said that there in one GSM band there are two antennas, one for what? Transmission and another for what? Reception. It's not like that. Okay, though the uplink downlink frequencies can be different, that antenna can have multiple resonance and all. Why this is so? Because reciprocity theorem is very much applicable to the antenna. Okay, so you may teach electromagnetism or you may not teach electromagnetism or antenna and all, but this thing you must know. Basic fundamental. Okay, that's why in second year we learn theories and all, theorems and all. So therefore you will find that integration with other components. When your antenna is designed and when you connect it, there if some fault is there, even the soldering is poor, it won't give the related or required coefficient of reflection, or what we call it as return loss in general practice, which we minus dB. Okay, so instead of taking energy from the circuit, it will load it and throw back to it, and rather standing waves will get generated. Standing waves, what is, they define the purpose, they never transfer energy. So standing waves is a disadvantage, it's not required. Okay, that's why SWR ideal value is 1. Okay, coefficient of reflection ideal value is 0. This you must achieve. So instead of 0, we say that return loss should be negative, and SWR, even if practically you get 2, then also you will say that बहुत अच्छा antenna for all practical purposes. That's why it's integration. Integration, if at the IC level, if it is there, what you will do? You have designed an antenna which is fractal geometry based. Okay, since it is a keynote, I have not gone into one particular type and many technical details and all. पहले ये तो पता ही थी. Okay, that's why I said challenges and issues which are there. Now you have designed very good antenna, millimeter wave, this, that, but now it is to be put inside an IC which will be part of some BP checking machine or something like that. Okay, now उसको integrate करना है पूरे circuit component के साथ. So many parameters we will have to comply. अब अगर आप अलग-अलग division में काम कर रहे हैं, if you are in BEL or Qualcomm or say NVIDIA or something like that, and if you are in antenna division, they will simply come and will say, okay, you design this dB, इतना gain, इतना return loss, इतना ये ऐसा 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 फला हो गया तो you don't know what will be there in front of it, after it, or what will be there before it in the chain. Now you just imagine what kind of precision your design must have or should comply so that it is working well with all integrated components. Either it may be a device or a power supply or a source, whatever, oscillator, या कुछ भी रह सकता है. ठीक है, this is the case. That's why. Then beam forming and steering, ये तो सबसे बड़ी सरगर्मी. ठीक है, like omnidirectional, if it is there like your internet routers and all, then no problem is there, because there ideally it is expected that that antenna should radiate equally in all directions. Okay, but many direction based applications are there. So imaging is there, or satellite this thing is there, link and all, where a Mangal mission, इतना वहाँ कितना precision होगा, the calculations are to the 10th place of the decimal. ठीक है, और mobile itself, one tower catering so many users at a time. Now dynamically the minor beam you are converting into major because user has moved from here to here. Now the direction of arrival of the signal DOA has got changed, and it's a 3D thing. Now it is in terms of what? Azimuthal, phi, and elevation, that is theta, both together. Okay, so when signal is known, so many beams are to be formed dynamically. That's why एक सिर्फ टावर पे हमको एंटेना दिख रहा है, बट उसके नीचे हेवी कंट्रोल प्लेन है जो मिलियंस ऑफ बिट्स का डाटा प्रोसेस कर रहा है रियल टाइम. ठीक है, that's why we have a myth that antenna means only that metal part and this. No, antenna means you can be very expert in various signal processing algorithms based on which smart antenna work. An intelligent antenna cannot be a dead dumb metal body only. It will be that supported with the entire intelligence or circuit or that kind of thing. Got it? So therefore, beam steering, beam formation, switching of beams and all, this is also very, very challenging thing. And environmental sensitivity. So you see many WhatsApp university or articles, they keep on coming, this frequency is dangerous, we have that effect and exposure and so on. So far, nothing has been proved in the lab, frankly speaking. Okay, अति किसी भी चीज की वो तो बुरी. Okay, now many people have a habit of keeping their mobile phone below pillow while sleeping. This is very bad. उसके लिए थोड़ी बनाया है. Okay, you should minimum keep it 1.8 meters away from you. फोन करता है, बहुत लोगों को आदत होती है कि सोते वक्त उसको चार्जिंग पे लगा के अपने बाजू में रखते हैं. हाईएस्ट रेडिएटिंग है उस समय. ठीक है, एंड जब चार्ज पे लगाया है तब भी बात करते हैं. 1000 बार बोला कि ये नहीं करते, उसके लिए नहीं करते. नो वन इवन रीड्स द इंस्ट्रक्शन ऑल्सो. मोबाइल का डब्बा खोल के स्विच ऑन करके सेव डाल के यूज करना चाहते, क्या लिखा है जाना. मतलब tomorrow if something happens, company has already made it clear, आपको इंश्योरेंस का एक पैसा नहीं मिलेगा, because you have not adhered to the standard safety practices of the device usage. So environmental e-waste, what the so the kind of material you will be using and all, can you bring origami principles? Can there be optical antennas which can suffice for purpose of lighting also at the same time? So the dual functionality can be there. These kind of so many challenges will come in picture and all. So this is like when you go for high frequency or millimeter wave components and all. So different types of these components can be there. Now out of it you can design the power combiners, filters or amplifiers or antennas and all that is there. Because see your topic what you have written is nothing but RF design and antenna. This covers both. Okay, so that's why this kind of challenges or issues would be there. Now I will go for some basic design or case study based experimentation what we did rather, and what kind of challenges were there and all and that. So simple first this thing was when the computer center was there. Our effort was to give the software defined radio capability to the devices like laptop and all. Okay, so if you just recollect, just 8 years back or 10 years back, your laptop was not having even Wi-Fi capability also. Okay, you have to connect a special module to it and then it used to this. After that, they created one PIFA antenna, which is patch antenna, which is merged in your screen. Okay, and through transmission line, it has been connected to the RF model, which is embedded in your keyboard. Okay, this is the case. And then now laptop is capable of catching the Wi-Fi. This is the evolution of the technology. Now, whenever SDRs are talked about, okay, or cognitive radio and all in communication, we talk a lot. So in that case, we say that कि बहुत सारे spectrum licenses ऐसे ही पड़े बिना use किए, and that's why you should use that bandwidth and transmit when you don't have channels available anymore. Okay. So in a place like airport where millions of people are there, even if you provide Wi-Fi, there can be congestion. Okay, overloading of the network and all these kind of things are there. So can your laptop have for reliable communication a capacity where it can shift from one frequency to another, find a free spectra available and do the transmission or reception on it and again come back to its original designated distance. Okay, this is what the job the software defined radio does. Okay, but इसमें बहुत सारे commercial legal issues भी involved है. Let's not talk about that or go into that detail. But thing is your laptop currently having that capability? Is your mobile having that capability that if I go to some Andaman island and all and there I find that no network is there, so it has shifted the band, gone to the satellite communication, did the communication again come back and all. Right now the answer is no. Okay, so we thought to have the RF module created which can be generalized and can get connected, okay, to any particular such gadget or device, and then it can give the device the software defined radio or cognitive radio capabilities. Now when this is to be formed, then you will keep in mind that ये अगर आपको करना है, so then you need so many things. Now first thing is you will have to sense or scan the spectra. Okay. Now, when you want to find out the free slot of frequency, scan the spectra. Scan the spectra means what? You have to literally design a receiver which has a very large what? Bandwidth. And what it will do, it will go through the frequency skip and sweep, and will keep on checking which frequency band is available. Okay, यहाँ मिल गया, ये इसको खत्म. But then from start to end, to make a sweep, okay, if that oscillator is changing frequency and sensing the energy and scanning is going on for the, which is called as spectrum sensing, okay, then your antenna should support that. Okay, आ गया पहला चरण. Now, if you want to use software defined radio capability, then कितना band scan करना चाहोगे ideally? If you want to find the free frequency slot, how much spectra you would like to scan? Obviously what? As high as possible. Theoretically infinite. Can we define a receiver with infinite bandwidth? No. But then RF amplifier or circuit with very large bandwidth if we want to design, which is doing job of frequency field based scanning and all, it will be a complex operation and your antenna should support that. So that's why ultra wideband spectrum sensing retransmission system for this. And for that the antenna is to be designed. अब यहाँ प्रॉब्लम क्या है, ये तो एक पेज है, पहले वो देखेगा कहाँ कहाँ खाली है, दिस इज फर्स्ट पेज. वंस लॉक अवेलेबल, अब क्या, shift your signal from that frequency to this frequency and retransmission. Now this job is simultaneous, okay, and that's why a lot of reconfigurability will be needed in scanning as well as in retransmission. Therefore you need two antennas, okay, for scanning and all. Based on this AI/ML technique, real time you have to process this through hardware and get this thing done. Okay. So on that module, 3 students were there who were working on it. One was working on the RF module, one was working on the scanning antenna, and third one was working on the reconfigurable antennas and all. So you can see that spectrum sensing, spectrum allocation, and then reconfiguration and transmission. This would be there. This is that block schematic. You can clearly see two antennas, one for sensing, another for what? Retransmission. Okay. So right now we will focus the entire discussion on this particular part only. So this implementation where is concerned, okay, the application was divided into 3 parts. One RF part which does the processing, one would be the sensing part, and one would be the transmitter part or reconfigurable transceiver which is to be designed. Therefore, the spectrum sensing antenna which we require, that we are having this kind of parametric specifications which is required. Any antenna if you want to design, you must first know what are the requirements. Like here we know that the SWR should be between 1 to 2, the return loss should be less than -10 dB, omnidirectional radiation pattern is required and all, and the required frequency range is most challenging, which I am asking it more than to work on 7 GHz band, which is very wide band, okay, for a normal antenna to work. Therefore, you will find that when this was done, then we went through the literature survey and studied many transaction papers and this and that, what kind of antennas people have designed so far, and also it was decided that a patch antenna would be suitable for it. Okay? And very simple design started with just circular patch. Can a circular patch simple do your job of spectrum sensing or scanning or not, that we were finding out. And the challenges started. Okay, so we thought that okay, this first base design with a subset of this particular dimension we would go for, and we will design this kind of circular patch and all. But then you will find that insect field was given, then it was removed and its impact was seen, and then it was seen that the first version particularly is not up to the mark again. You might be getting resonance and all, but the radiation pattern also was not satisfactory, and particularly the kind of result we wanted was not there. So then we included the finite ground plane in the same thing. The moment that particular thing was added, okay, you can find here the effect of finite ground plane was that multiple resonances you can have, and the bandwidth stability is also there. Okay. So this is how the antenna design gets evolved one after another. With this also, it was simulated and found that okay, now with this, what kind of parametric analysis outcomes are there. So resonance we might got, but still again it was not that satisfactory. So gain or directivity or this was there. So then we knew that copper loss is to be reduced now. Okay. And therefore a slot was made in. So earlier it was just circular, now it will be with a hole. Okay, this is the case. So that is how we will start improving the design, and therefore hole means we chop that head shape here and make it spanner head kind of. Okay. Now how to decide that? For that you have to see the current distribution over the antenna. And where the effective radiating power is there, where you want and where you don't want, based on that this slot position and dimensions can be decided. So here you can see this kind of hole was made, and now it's look like a spanner. Okay. So you can say spanner shift. So circular got changed to spanner shift. Based on it again the parametric analysis can be done. The design further goes and you see now the simulated result is showing quite a good bandwidth. 7 was expected but it is showing up to what? 9 gigahertz. Okay, this is the case. So as the proper loss has been minimized and all. Then radiation pattern also in 3D way you can find out for different frequencies if we want to make it to work, then whether they are satisfactory or not, and typically omnidirectional or not, that we can find out. Okay. Ultimately, the testing would come. Now that is what I said through Computed System Center of Excellence. This is the NI National Instrument PXI chassis, RF embedded testing platform. Because that frequency sweep would be required, it would fit to antenna and will try to see whether it is scanning the spectra or not, or sweep is there or not. So this is through LabVIEW, this interfacing application was made, and the first version of antenna was it was excited here. Okay, this you can see that photograph here is showing. So it was placed and then tested, and therefore then the domain analysis of the ultra wideband patch antenna was done. Okay, so slowly you can see the design gets evolved now. We made it to spanner this thing, additional holes still to further reduce to the copper loss this thing has come. And with the ground plane back was there already. And then we could see that here you can see the measured results and the simulated results. Two curves, not perfectly matching but almost making or following each other. So for practical design, if this kind of results come, then we say, okay, these are good results. So, and this is the vector network analyzer where the measurements were done to find out the return loss and all. Probably Professor Moratkar can recollect. This was the VLA kept in VLSI lab, only 20 gigahertz range was their key site made. So, and now we have 42, which is this size. This is tabletop model, earlier screen where they now simply connect it to laptop and start working. Okay. So sleek they have become now. So this transmitter setup was there. These are the RF modules which are designed, and clearly you can see here the antenna is connected. This is integration now. So to this circuit your antenna should work with them. Okay. So if impedance matching is not there, then again there would be what? Problem. Okay. And that is how for retransmission or scanning, this test setup was made. This is the transmitter setup and receiver setup. So receiver setup, this RF system is there, and this is the scanning antenna. So your VNA will give it a sweep. Based on it, you can check out whether it is really scanning the entire band or not, or white point it is working or not. Now using this, the future scope was there. You can use it and design this thing. Now this RF module details I won't discuss slightly. It is out of the scope of today's discussion, which was handled by the second student making the entire processing. Now this is what I was talking about. See PIFA antenna in a typical mobile phone. This is Samsung diagram. Okay, so this all these patches what you see are antennas different color. 1, 2, 3, 4, 5, 6. Okay, in one mobile phone, so many antennas working in vicinity, and your mutual coupling should be as low as possible. How to achieve it? It's a great challenge. Again. Okay, so this was the case. Now, what we want again coming, forget about RF. This is the second antenna, retransmission. Okay, now retransmission antenna should be like a very faithful शिष्य. जो क्लासिकल सिंगिंग में होता है, गुरु क्या करता है, ऐसी तार लिया तो उसको भी लेंगे. अब ये कौन सी लेंगे इसको पता है नहीं. So that talent is there required. So scanning है, we only know that it is a wide band, but कौन सा frequency उठा के लाएगा ये तो मालूम नहीं. So the retransmission antenna has to be that intelligent enough that it has to be reconfigurable. X से K, K से KU में, फिर L में, फिर C में. Which band you are talking about? Okay. Now naturally the device as a cognitive radio would be considered versatile enough only if it is covering for a larger band. अब इतनी सारी बैंडविड्थ पे और सारे फ्रीक्वेंसीज पे वर्क करने वाला एंटेना कैसे बनाएंगे? This is a very great challenge. Okay, so keep on thinking, and then we could realize that just one simple plain antenna structure for scanning it is okay, but for retransmission, such reconfigurability with so much multiple resonance over wide band cannot be obtained just by one structure. So what we will have to do then? So we will have to do some assembly of structure. ठीक है, ideas कैसे आते हैं एक के बाद में, ठीक है. So if you carefully observe, we gave this PIFA type of antenna, but उसमें क्या है, if you clearly see, this one antenna itself contains so many sections. So two C section, ये दो C हैं, then two E section, one plane E and inverted E, and one I section. Could you see it? All of them are simple sections patch antenna, but coming together, and in between them, this time what we are introducing is nothing but active switching components like pin diode. Now switching, what it will do? Either it will take that radiating branch or part inside the assembly, or will exclude it. Okay, that means I will switch on the diode. Now in all, how many diodes are there? You can count here. So around 6 are there. 3 plus 3. And 6 diode switches. If we just apply binary logic also, still we have so many combinations. 2 to the power 6. Okay, so what will happen? 2 to the power 6, 64 switching patterns would be there. Based on it, for example, I can only say that this time everything on only I will radiate. Only I will radiate as an active component. So it will be just one antenna working on certain frequency. So this was the idea. Now can anybody put a wide guess कि idea कहाँ से आया होगा? This antenna design is influenced by a very simple idea which we all electronic engineers see in our everyday life. Huh? No. I'm saying some device or entity जहाँ से idea आया. Not as a technology. Okay, actually it should have struck your mind immediately. 7-segment display कैसा work करता है? Okay, how do you produce 0, 1, 2, 3 from same this thing? General figure is what? 8. Okay, from that we produce all figures. So if we say 2 is required, then we will eliminate the respective wings, and the non-required wings will be what? Off. Same. Okay, naya. So that is our challenges, issues, try to overcome it. Some basic ideas will work for it. Okay, this is the case. Only thing is cost of involving the active components into it. When this was made and the surprising results were there, you will find that the simulation, multiple resonance, so many frequencies, current distribution satisfactory, increased gain, and so on. This is the final fabricated prototype you could see here. And then you will find that when this is done on VNA testing, major figure similar, and now see what it can do. See the wonders. So starting from so many modes or patterns in which they all are on or off or some on off, whatever is there. Could you see when all are on, see the frequency range which it is covering? Comma hai usko. Means when all are on, it can work on what? Clearly can see 1.5, 4.4, 4.7, 5.7, 4.6, this, that, so many frequencies are active. It can work, it can shift. So now this antenna has completely become like that faithful Shishya which can follow its guru, whatever versatility is required. So just go for 64 switching patterns and you can get something. Now who will do that? इसको practically generate करके देखना पड़ेगा. So that's why again lab was dropped. Okay, and the entire setup then was made, switching this thing again coming to the PXI chassis. अभी देखो यहाँ पे lab का भी programming, antenna में कहाँ कभी सोचा भी नहीं. ठीक है, so one student has made that spiral antenna for scanning. ठीक है, एक ने बनाया RF मॉडल, तीसरे ने क्या बनाया? Reconfigurable बनाया. Complete assembly together, what it will give me? Cognitive radio capability. ठीक है, कब किया? 2016 or 15 का प्रोजेक्ट. ठीक है, think ahead of time. Now I can reduce it to MMIC design in current scenario. Okay, now both these students who were, or rather both these 3 students who were our regular MTech students, guest score and all. Two of them were, all three of them were from Kerala. Okay, one of them is BEL on a very good scientist position, and rest of two have pursued PhD at University of Liverpool and have become professors or industry person and all like that. It is there. So that passion is required. Okay, one idea is given. You have to, if environment is there, you can easily do it. Nothing sort of rocket science would be impossible. I am not discussing any such complicated manner or telling you all basic things with them. If your fundamental or basics are strong, you can take over it. So this is the PCXI chassis switching pattern controller was made, and based on it particularly this was there. This was one such application. Then one I told you that we made a zeroth order resonance millimeter wave antenna for concentric detection. And that time he was working for more than 30 gigahertz. No facility was there. Now this fellow research scholar of mine is a respectable faculty at IIT Nagpur. He is independently working now. He is working on many things. Okay, this is the case. But that time during PhD, so many challenges, right from fabrication, testing, everything. Now, what is the application? That is what I said. And that's why when people come to me, sir, we are doing PhD in antenna. First thing I ask is, what is application and which frequency band you have to do? They are not sure on it. Why? Very poor literature review. Okay, as a trial and error, trial and error, trial and error. These practices are there. I'm not commenting on university practices and all, but people are just after feel trying to be, and then things are found that the guides are there, those have not worked at all in antenna. They are doing something, doing on antenna, anything, any कुछ भी चलेगा ये होगा ऐसा थोड़ी चलता है ऐसे से तो सब हो जाएगा कॉन्फिडेंस के लोगों में थीसिस दे दो रिव्यू होके भी आ जाएगा तो एक ही पैरामीटर है मतलब 2 साल हो गए क्या 3 साल हो गए क्या 3.5 साल हो गए मतलब अरे बहुत हो गया इसकी तारीख कर Why is it like that? Because we want compliance. हमको भी तो एक डिग्री चाहिए ना फिर मेरे को एसोसिएट प्रोफेसर का मिलेगा फिर मैं प्रोफेसर बन जाऊंगा यही अगर करना है तो फिर पीएचडी कर ही क्यों नहीं तो ऐसा क्लियर रखो कि नहीं वो अपने को जस्ट फॉर द सेक ऑफ कंप्लायंस करना है और मुझे पता है कि पीएचडी में कोई दम नहीं है डिग्री के लिए डिग्री ली है एंड आई विल गो विद दैट पर्टिकुलर रूटीन व्हाटएवर इज गोइंग ऑन बट देन डोंट बिकम नर्वस कि सम ऑफ योर कलीग गेट सिलेक्टेड इन ट्रिपल आईटी और एनआईटी और अ गुड कंपनी और उसका कैसे एफर्ट्स आर देयर ठीक है सो एक रियल कॉइन जो कि डुप्लीकेट नहीं है उसकी आवाज खनक कभी भी कहीं पे भी नहीं सर्वाइव स्टार्टिंग सो इट ऑल डिपेंड्स ऑन अस एक सिंपल एक्सपेरिमेंटेशन करना है तो 25-30 पेपर पढ़ेगा तो होता ही he has worked under Professor Parthikan can ask him how many papers he used to ask to read ठीक है this is always there unless we go through it then all these things will come अब इसको I will just take your 5 minutes since case studies are there so here you will find that design methodology and other aspects we would just do what was there we had that tragedy of 7th July something when there were the explosions through the bomb in the locals of Mumbai and all. July 26th July then. So what we thought that we will make a wired network. Okay. Now see through literature survey it was found that millimeter wave antennas can be used as nodes sleepers. मतलब if you design a pulsating lidar based on this frequency range and send the signals. It catches the reflected signal and it tells you which type of material is this. So it separates out explosives from other materials. So this is electronic node. That's why the title, if you could see, is concentric detection. Okay. For that now as a sensor which can be used, that kind of antenna you have to design. Okay. So if antenna is to be designed and to be used as sensor, so our idea was such antenna based sensor with electronic module, one node would be there. We will make a network of such node. It will be placed beside seats and all like that it is there and there would be node communication controller ultimately the driver would know that in S7 ठीक है, near 56 this thing there is something which is fish alarm. ठीक है, so what you will have to do is you have to create that network. This will have to be a scanning network. अब प्रॉब्लम ये है कि मिलीमीटर है, so the waves have penetration capacity वो अच्छी है, but range 8 मीटर से ज्यादा है. ठीक है, दैट्स व्हाई एयरपोर्ट पे आपको मैन्युअली स्कैन करते हैं. ठीक है, सो व्हाट वी विल डू हियर, आप एक्सप्लोजिव रखे तो पता कैसे चलेगा, किसी ने कुकर में रख दिया क्या हुआ, और कुछ मटेरियल्स को फॉल्स पॉजिटिव भी नहीं देना है. ठीक है, तो टिपिकली टीएनटी या जो आरडीएक्स एंड ऑल जो यूज होता है अमोनियम नाइट्रेट है, ये आना चाहिए पहचान, डिटोनेटर्स वगैरह अगर है. ठीक है, that's why how to go about it, and that's why it was there that millimeter wave frequencies are very good, but 1 मीटर है तो फिर क्या करेंगे. So there will be listen and talk. ये नोट्स का ही नेटवर्क रहेगा. ये बोलेगा मेरे लेफ्ट में कुछ है, ये बोलेगा मेरे राइट में कुछ है, like that they will keep on finding. So like a radar, if there 1 meter this thing they will keep on scanning. ठीक है, so यहाँ पे भी फायर कंप्लायंस होगा तो स्मोक डिटेक्टर लगाते हैं. Now, what is the advantage? Since it is a fixed topology, I don't have tension of routing and other things. ठीक है, जो वायरलेस सेंसर नेटवर्क में बहुत होती है, ये वायर्ड है. ठीक है, मूविंग का तो रखने का बर्फ के नीचे ही लगा के रखा है ना, सारे सेंसर लगा के. ठीक है, एंड इवेंचुअली बैकअप वाज देयर कि उसमें से एक से भी सिग्नल नहीं आ रहा है, तो डैशबोर्ड पे पता चलेगा कि किसी ने उसको ट्विस्ट किया या कुछ किया, तो वो मेंटेनेंस तो किसी भी चीज को लगेगा. that you have to keep on periodically checking it. But this kind of network was there, so much thought press. Then अब frequency decide करो, then decide करो. अब प्रॉब्लम ये हो गया कि डिटोनेटर्स they falsely get triggered due to the scanning of this only. जब एक्सप्लोसिव ट्रांसपोर्ट होते हैं तो यू हैव टू टेक लॉट ऑफ केयर, उसको बोलते हैं पैसो. और सेफ्टी कमिश्नरेट का ऑफिस एक्सप्लोसिव का सिर्फ नागपुर में है इंडिया में, बिकॉज बाजारगांव और अमरावती रोड इज कंप्लीटली बेट ऑफ. सोलर कौन था फिर, सोलर कंपनी वॉज इनिशियली an explosive company only. Now they have gone into defense production also, so have become so big and rich. Okay, so you will find that handling that van nowadays, that van is very crucial. पहले तो माइनिंग के लिए ले गए, ब्लास्ट किया, ये किया, बट आप कोई 50 जिलेटिन स्टिक उठा के ले गया तो दैट कैन बी यूज फॉर एनीथिंग. दिस इज वेरी वेरी डेंजरस. कहाँ गए, ट्रैक करो. दैट्स व्हाई दैट वैन जब घूमती, अब आप बोलोगे कि मोबाइल है ना, वो ही ट्रैक करो. ठीक है, वहाँ ऐसा इलेक्ट्रॉनिक डिटोनेटर वगैरह होंगे तो मोबाइल से ही वो एक्सप्लोड हो जाए, फॉल्स ट्रिगर हो. So then we found that the mode of wave जो है वो zeroth order ही लगेगा, zero port में. That's why ZOR antenna, zeroth order resonance और एक restriction है for design. So zeroth order resonance antenna is to be designed, that to at millimeter range. अब ध्यान में आ रहा है कि ये एक पैच एंटीना से होने वाली चीज ही नहीं. And secondly, the method used will be non-imaging and the radiation has to be non-ionizing. अदरवाइज इट विल जो रखा है उसको ही वो और ट्रिगर करे. ठीक है, दैट्स व्हाई नॉन कांटेक्ट दिस काइंड ऑफ थिंग इज देयर. अल्टीमेटली लुकिंग एट दिस बैंड वी कुड सी थ्रू द लिटरेचर सर्वे दैट हियर देयर इज अ स्कोप इन मिलीमीटर अराउंड 30 gigahertz range. If we could use this, then the purpose can get solved, and therefore it was showing that what kind of response it gives to the explosive material and all. ये particular band. So it was pursued, and then finally it was decided that the excitation would be zeroth order resonance, and the beam scanning or switching would be designed by us, so that this is the zeroth order field excitation which would be maintained over it, so that electric field should not trigger false explosion and all. यहाँ से जर्नी चालू हुआ. अब मिलीमीटर बोला तो साइज एकदम कम है. ठीक है, but then patch antenna again, how it will be. Now if we take patch, then see, for the understanding the coin has been kept. That means आपको समझ में आएगा कि एंटेना का साइज कितना छोटा. ठीक है, now if the antenna is made to be made as a sensor, and if you are making patch, how it will be omnidirectional? ये planar है ना, planar antenna, how it can look around it 360 degree? ऐसा हो ही नहीं सकता, ठीक है? Then so many things started. ये चालू हुआ, the design got evolved, interlude capacitance उसने बनाया, ठीक है? कैपेसिटेंस इंक्रीज करके जो वेरिएशन गेन डायरेक्टिविटी चाहिए थी वो लाई, ठीक है? बट somehow again the results were not there, so that IDC structure was loaded, radiation pattern simulated, major results, everything was done, but then mutual coupling analysis also was done. अब ये क्यों, एक से ज्यादा क्यों आप सोच रहे हो? सिंपल, अब भी मैंने बोला कि वन एंटीना इज नॉट कैपेबल ऑफ लुकिंग अराउंड इट, ठीक है? दैट मीन्स व्हाट, उसका रेंज लिमिटेड रहेगा, ठीक है? नाउ सिंपल, इफ वन लाइट कैनॉट थ्रो लाइट अराउंड इट इन द एंटायर रेंज, व्हाट विल यू डू? मल्टीपल लाइट, झूमर कैसा रहेगा, ऐसे फोर लाइट 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 लगा, सेम। So we decided to make a conformal array, okay, and each antenna would cover certain range, all together will take care of 360 around it. ये एक node हो, and like that there would be what, multiple node RF excited. That was the idea. But then we were still facing challenges. Mutual coupling कम नहीं हो रहा था. Then again variation दिया. Then finally we could know that the gain is very poor. अब उसका enhancement कैसे लाएं? So you check out the current distribution. So if that is to be done, then finally we could realize that you can go for it if you use a staircase IDC structure. ठीक है? आपको एंटीना में कुछ रिजल्ट साइंटिफिक इससे मिलता है, कुछ ट्रायल एंड एरर से मिलता है, ठीक है? और पीएचडी में ट्रायल एंड एरर से भी मिला होगा, तो भी थीसिस लिखते वक्त आपको फिर रिवर्स इंजीनियरिंग करके उसका साइंटिफिक एक्सप्लेनेशन लिखना पड़ेगा कि ऐसे, ठीक है? अब आप एक ही बात ध्यान रखिए, वॉट एवर आई एम डूइंग, स्टेयरकेस, दिस दैट, आईडीसी स्ट्रक्चर, वॉट एवर, बेसिकली आई एम प्लेइंग विद एडजस्टिंग वैल्यू ऑफ एल एंड सी, बस, दूसरा कुछ नहीं, जैसा मुझे चाहिए. That reconfigurability I have to bring into picture. Finally, this was there, this got evolved. Connector ही उससे ज़्यादा बड़ा है, ठीक है? You can see. And based on this, अब ये challenges शुरू हो गए. एक तो बना, अभी array कैसा लाऊंगा? This was the proposed system. ये, so entire proposed system is brought with the support electronics. It will send the signal and will get the reflected signal, process it and will give the alarm. This is one node. तो यहाँ जो है पूरा सेंसिंग में, ये आपका क्रूशियल सेंसर है, which will do the job of transceiving, that means transmitting as well as receiving. So array बनाना पड़ेगा. तो array, अब array कितने का बनाऊं? Next question. Whether there should be 3, 4, 5, hexagonal, pentagonal, triangular, again वो प्रॉब्लम है. बेस्ड array चाहिए, एक्साइटेशन कैसे रहेगा? एक ही एक्टिव रहेगा, दो पैसिव रहेंगे, तीनों एक्टिव रहेंगे. So many questions which will serve your purpose. So Yagi-Uda aerial, which sir was referring, that taller antenna we used to have, actually if you see what it is, उसका optical equivalent निकाल. So if I take a bulb, then behind it if I put a mirror, what will happen? If I put mirror behind it, what will happen? The light would become directive. Okay, means light itself is throwing the light in front direction, but because of mirror as a reflector, the light going in opposite direction will also get thrown into same direction. In this assembly, I have made it directive, point to point. एक ही दिशा में काम करना है आपको, omnidirectional, ठीक है? अब उसमें भी मैंने क्या कर दिया, लाइट आ रहा है, but it is not focused, हाई एनर्जी बीम नहीं है, तो इस साइड एक लेंस लग दी है लाइट के साथ. अब ये लेंस क्या कर रहा है, ठीक है? It will take the light coming from the light source itself as well as from the mirror and will convert. अगर एक convex lens कर दूँ, एक high focus beam बनाएगा और डायरेक्ट करेगा. So what is happening is, one is active source, another is what, reflector. सामने क्या है, डायरेक्टर. यही तीन आप यागी-उड़ा एंटेना में यूज करते. बीच का फोल्डेड डायपोल सोर्स, whether receiving or transmitting, दोनों, like that it is there. So that's why active passive array बनाना है. अगर कुछ भी optical equivalent एंटीना वर्किंग, immediately समझ में आएगा. This is the case. So now 7 element, this element you can make. So here also the array analysis was there. Then lot of computation were there. Then beam steering या जो है around 360 scan करना है. So should we switch it or should we go for steering? That means एक ही beam को आप अलग अलग एंगल से जैसे टॉर्च से आप फोकस करते हो हाथ घुमा के वो करना है या 5 टॉर्च रख दो एक ऐसा एक ऐसा एक ऐसा और उसको थोड़ी थोड़ी देर के बाद सबको ऑन करो अभी तू अभी तू अभी दो में फर्क ठीक है सो डायनामिकली मूविंग वन टॉर्च एंड स्विचिंग मल्टीपल टॉर्चेस वन एट ए टाइम सो वन इज बीम स्विचिंग अनदर इज बीम स्टीयरिंग अब बीम स्टीयरिंग में यहाँ हाथ घुमाओ बोला बट मैकेनिकली एंटीना में कुछ नहीं घूमेगा सिग्नल प्रोसेसिंग से सब आपको करना चाहिए सो अभी मैंने यहाँ बीम बनाया बट अब मेरे को इस बीम की जरूरत नहीं है तो आई विल गिव एंटी फेज वेव जिससे कि ये बीम नल हो जाएगा और दूसरी तरफ जो माइनर है उसको एडिटिव स्ट्रेंथ दूंगा तो वो मेजर हो जाएगा और ये रियल टाइम में करना है ठीक है सो दैट एंटायर एनालिसिस फॉर द एरे वाज डन स्कैनिंग सीइंग स्विचिंग क्या करना है वेदर 4 5 लाइक दैट सो ये सब हम आगे ले जाएंगे तो सीआरएलबी और इसकी कंप्यूटेशन एंड ऑल अब ये पूरा सिग्नल प्रोसेसिंग आ गया डीएसपी में आप करते हो ना फीडबैक बेस्ड है सो वेदर यू विल यूज लीस्ट स्क्वायर मीन एरर एल्गोरिथम और म्यूजिक और एस्प्रिट और लाइक दैट यू हैव टू थिंक अब इन्होंने चूज किया दी दिस थिंग म्यूजिक एंड डायरेक्शन ऑफ अराइवल एस्टिमेशन को एनालाइज किया तो एंटायर सिग्नल प्रोसेस अभी एंटेना अपने को लगता है वो काम ही नहीं करेगा जब तक ये उसके पीछे नहीं घुसा तब तक आपकी एप्लीकेशन सॉल्व नहीं होगी ठीक है सो दीज आर द चैलेंजेस एंड इश्यूज लाइक दैट एंड फाइनली सी वी हैव कम विद द फैब्रिकेटेड सेंसर एरे विद दिस 5 फिल्टर किए हुए like the choice was made and that for that also the particular results were there this sensor one node and this is how from this was the entire contribution was made and this was there now like this so many antennas were designed these particular antennas which now I am showing are for wearable technology in body on body off body ठीक है different application अब इन एंटेनास का डिजाइन सबसे बड़ा चैलेंजिंग क्या रहता है इफ यू से दैट दिस एंटेना ऑफ माइन वेरिएबल विल बी यूजफुल फॉर ह्यूमन बॉडी दिस वेरिएबल वॉच और ये तो सबसे पहले ये रहता है कि जब आप उसको सिमुलेट कर रहे हो ठीक है यू कैन नॉट सिमुलेट इट एज एन इंडिपेंडेंट एंटिटी इन एयर you have to always simulate it considering that the phantom is present that means वो हाथ पे ही है ठीक है so electric profile electronic profile of hand ठीक है from material engineering point of view हमारी बॉडी का या ह्यूमन फ्लेश का एप्सिलॉन कितना रहता है वो प्रोग्राम करके उसके ऊपर वो एंटीना रख के ही सीएसटी एचएफएसएस आई3डी कैड फिको जो भी टूल आप यूज कर रहे हैं उसमें वैसा ही सिमुलेट करना पड़ेगा अदरवाइज क्या होगा if you do lone antenna simulation results will be very good and moment you put it on hand there is total attenuation groundwork not working around this plane you have given and the results are not come I was saying so that simulation is required to phantom अब ये शुद्ध शाकाहारी स्टूडेंट और मेजर रीजन सिमुलेशन में तो आपने आर्टिफिशियल लैंड बना के एप्सिलॉन डाल के फैंटम डाल दिया मेजर रीजन वीएनए पे जब एंटेना मेजर करेंगे फिर से अब सिमुलेशन में अगर बॉडी चाहिए ह्यूमन फ्लेश चाहिए तो इस पे भी कैसा चाहिए वीएनए के वक्त भी क्या रहेगा चाहिए नाउ these are variable applications so medical council of india does not allow you to use human as subject नहीं तो authenticity zero आपने को लगता है उसमें क्या पेन लो और दिखाओ रिजल्ट ठीक है तो इंटरनेशनल पेपर पब्लिश ही नहीं होगा एससीआई अनलेस दिस थिंग हैज बीन उनकी परमिशन दी गई थी दिस विल कम लास्ट दैट मींस यू कैन नॉट यूज ह्यूमन बीइंग टू टेस्ट दैट कि अपने हाथ पर होने कुछ नहीं वाला बट दैट इज नॉट अलाउड इट इज दोस रिजल्ट्स आर नॉट ओके अभी क्या करना देन इट शुड हैव सेम एप्सिलॉन दिस थिंग देन दिस फेलो अंडा भी नहीं खाने वाला लेकिन उसको रोज मटन और चिकन लाना पड़ता है तो बाजार ठीक है और हैम स्लाइसेस जैसे स्लाइस बना के लेयर बीच में कीमा फिर लेयर फिर ये और वो गोट मीट रख के उसके ऊपर फिर वो एंटेना रख के देन टेस्ट ठीक है, अभी लोगों को खाना खाना है इसलिए वो फोटो यहाँ मैंने डाला, ठीक है। बट सी दैट इज व्हाट आई एम सेइंग, रिसर्च इज नॉट दैट इजी, आप रिजल्ट प्रूव कैसे करें? So electronically that entire structure with the same epsilon has to be first reworked, authenticated, approved, and on that the same consistent results or cycles are to be tested. तब आप बोलोगे। अब ये तो ठीक है कि उसको ट्राई स्टब दे दिए, सेंटर फीडिंग दे दिया, फाइनली व्हाट हैज बीन अचीव्ड, यू सी what compact antenna has been made. The size is very, ठीक है, suitable for various applications. So many applications, these things, miniaturization has been done, and for particularly they can be done. Now one during COVID only, because of the need, one of my UG students, she did a very good work. She was playing with the antenna in the lab and then she realized that उस पे हाथ पे रखा और ऐसा ऐसा किया तो उसका रिटर्न लॉस जो है S11 वो चेंज हो जाता है, ठीक है। So if you move hand means what you are making gestures. So then she took the project gesture identification using antenna, ठीक है। गायरोस्कोप इज व्हाट, हाउ मोबाइल नोट, ऐसा किया कि स्क्रीन पलट कैसे जाती, स्क्रीन रोटेट्स, दैट मींस सेंसर इज देयर, सो कैन एंटीना डज दिस, ठीक है। एक स्टूडेंट गया समीर में, दोज आर वर्किंग ऑन वायर्ड एंटीनास व्हिच इज यूज्ड फॉर लीवर कैंसर एब्लेशन, ठीक है, सोनोग्राफी कैसे करते। So if that probe is ready, finally, no need of radiation and chemo and all. You just take that thing. If it is working, you keep on moving on the surface for certain time, and the cells would get burned. Cancer treatment. Okay. Low Tesla coils for MRI can be created. Okay. Using antenna. RF imaging to already established. You can use antenna to scan. So whatever return signals are there, those are to be converted into images. And that is how you can use for RF imaging different kinds of things. So in US and all UK, if you go, the tunnels are there, those are using those principles only. And you will find that that RF imaging is completely used. आप सिंपली जाओ, आपको कोई टच भी नहीं करेगा, और आपने गन रखी है नहीं रखी है क्या है उसी वहीं पे दिख जाएगा सब कुछ। यू हैव टू जस्ट वॉक, यहाँ से जाओ खत्म। अपने कैसे पर्सनल इंटरवेंशन से सिक्योरिटी होती है, टच करते हैं, वो सब कुछ भी, यू हैव टू जस्ट वॉक, गो थ्रू द चैट, हैंकी रखा है कि पिन है वो भी दिख जाए, and without any privacy issues. These are all you see RF imaging is based completely on antenna. Okay. So with this setup, that girl at BTech level could publish 2 SCI papers. Okay. And since the idea was unique, COVID nahi hai, so that's why now why gesture identification? She turned it that crisis into opportunity. कि आपने नोज को हाथ लगाया कि नहीं, whether you have brought your hand near to the face or not, that can be identified or not. Because patient monitoring आपको दूर से ही करना है. So take advantage of this. So very good antenna work and all that particular level was there. So once you take these things, students and even flexible antennas also sometimes we try to design. So this is gesture identification. So then she did MS from University of Texas, and right now finally she has gone into fintech now. Okay, earning a lot. Okay, but technically very strong. So now you see all these are nothing but results or graphs of S11 variations which are respective to the various actions. Clap कर रहे हो, क्या कर रहे हो, punch कर रहे हो, like that. So the gesture identification can be simply done with the help of antennas. This we will just skip the entire thing and all. Last but not least, frequency selective surfaces. So many of the speakers may cover this and all. But as I was discussing, there are various applications based on it. If you just complement the pattern, the frequency response changes. Okay. So this time here the stubs are there. This pattern is blank, and fractal pattern is there. The conformal also. So this is the fabricated surface and all. And this can be used as filters or for stealth technology and all. The reverse I can design, the reverse functionality would be there. So these would be actually microwave absorbers. Okay. And one student simply took the idea because उसका खुद का बच्चा लेगो ब्लॉक से खेल रहा था. So from there he picked up, can we have microwave absorbers which can be plug and play reconfigurable blocks, 3D printed. उसमें से antenna बनेगा. One of my MTech student has done antenna using principle of origami. बनाते हैं ना जापानीज पेपर, कॉपर शीट्स. ठीक है, ऐसे किया कि सी बैंड में वर्क करता है, ओपन हुआ कि एक्स बैंड में वर्क करता है, उल्टा किया कि एल बैंड में वर्क करता है, रिकॉन्फिगर. ठीक है, कहाँ यूज होंगे? सैटेलाइट में. सोलर पैनल ओपन होते हैं, same antennas you are using for different frequency band will give connectivity and reconfigure. Ideas are so many. ठीक है, only thing is you have to read a lot. हम में से कितने लोग न्यूज़पेपर ही नहीं पढ़ते रोज, तो कहाँ टेक्निकल और पढ़ेंगे. अब आई ट्रिपल स्पेक्ट्रम मैगजीन, सो मेनी इश्यूज, दे आर फ्री ऑफ कॉस्ट अवेलेबल. तो उसके लिए या फिर एक आई ट्रिपल की मेंबरशिप हम खरीदते हैं तो दैट कॉस्ट अराउंड फॉर 2000 रुपीज. अब मेरे को ये मत बताओ कि एक साल में 2000 रुपए का आप कुछ भी नहीं करते. ठीक है, ईटिंग, ये जीन्स भी नहीं आती उसमें अच्छी. ठीक है, दिस इज द केस. सो forget about one pair of clothes and go for it. So this is all, but ये थोड़ा microwave based ज़्यादा ये है, so it will take time and all. But we can show that literally 3D printed blocks and all this has made. Okay, and from that using copper strip and all and frequency selective surfaces can be created and all. Last but not least is there is a huge wide scope of AI ML in antenna technology. Okay, whether beam steering, beam this thing switching and other things are concerned. So many of your challenges of optimization of design and this thing that you can do for this. This is the this how AI can be used. So this itself is self-explanatory, where you can use artificial intelligence or machine learning in this way. Okay, so your signal processing or switching or this kind of things where you can use. And there are very good references or literatures are available on these particular aspects or content. So in all, I will conclude that I started with presenting the scenario basically. What are the challenges or issues we could have? And those are always application specific and how your own ideas can overcome those challenges influenced by simple things. So as we were struggling with the reconfigurable retransmission antenna, we got the idea from the 7 segment display. Okay, so you keep on reading all these things. First thing is in that particular subject aspect, any field I am saying, like DSP also I told you the example. The depth at which we carry the experiment and it is required right now in industry. If we don't listen, you should ask students that okay, take your photograph and remove the noise. This should be the DSP experiment. Okay, not the standard one to carry out this thing. And then they will realize that what 8 sample segment experimentation we do, they are not sufficient. Therefore, then they would understand the importance of add and overlap, add and shift. ठीक है, उनको इस चीज का क्या पता है? बहुत इंपॉर्टेंट क्वेश्चन है, मैडम ने बताया. ठीक है, और क्वेश्चन क्या आता है? डिस्क्राइब एड एंड ओवरलैप, राइट ए शॉर्ट नोट ऑन इट. वहीं सर फोड़ लो. बीएससी के पेपर में थ्योरेटिकल क्वेश्चन, इससे ज्यादा और क्या दुख की बात है. ठीक है, सो दैट इज व्हाट आई एम सेइंग दैट इंजीनियरिंग इज लॉट ऑफ एक्सप्लोरेशन. Read it, see where the world is going on. Nowadays, I have seen that there is immense trend of taking NPTEL certification by all the faculties and all. But when I see their content delivery or teaching, then I am equally disgusted or disappointed that none of it gets reflected there. Okay, if they are not enhancing the challenging quality of the delivery. Okay, since you all or most of you are faculty, that's why I am sharing this concept. Okay. And what has happened 25 onwards, the foreign universities have been allowed to have their campuses here. There will be whole electron theory. So those who were going to IIT, now they will go to Massachusetts since the campus is available in India. So NIT people will go to what? IIT. Okay, to NIT, BIT, रामदेव बाबा, गुड कॉलेजेस, वहाँ वो आएंगे. फिर आपको कौन मिलेगा? प्राइवेट में कौन आएगा? तो अभी आ गया ना सर्वाइवल. You see the trend. How many of you send your kids to the government schools now? You are wise people, you earn your own money. तो फिर ट्रिपल आईटी में और आपके स्टेटस पे फर्क ही नहीं है पीपीपी मोड में, सिर्फ वो गवर्नमेंट है और आप प्राइवेट एंटिटी है। मीन्स चैलेंजेस सबको है। ऐसे में अगर हम समझेंगे कि एक सब्जेक्ट जो हम पिछले 20 साल से पढ़ा रहे हैं उसको पकड़ के 10 से 5 लेक्चर लेके वो ही करेंगे, वी विल पेरिश विद इन मिनट्स। ठीक है, आज पेजर कितने लोग यूज करते हैं या कंप्यूटर कितने लोग यूज करते हैं कंप्यूटिंग के लिए? एवरीथिंग इज ऑन मोबाइल। जस्ट लाइक दैट विल हैपन। एआईएमएल हैज मेड आवर जॉब मोर चैलेंजिंग। स्किल इनकल्केशन पे ज्यादा स्ट्रेस। ठीक है, इसलिए एफडी पढ़ो, इंटरेस्ट लो, वहां से कुछ करो। ठीक है, ये करते करते हम में भी वो कैपेबिलिटीज आ जाती है, देन हम कंसल्टेंसी देना शुरू करते हैं। Now on top of it, there can be a contention or a thought in your mind that sir NIT में तो बहुत ज्ञान फिलर है। ठीक है, my association with the NIT is 19 years, but prior to that 12 years with all such unaided colleges only. 8 years I have worked with Priyadarshini. ठीक है, more than 4 years with Ramdev Baba. I am BTech of Ramdev Baba, MTech of YCC. ठीक है, Tech with faculty for Raisoni. You name the college, I will tell you. मैं भी 12 गांव का पानी पिया हूँ, ऐसे जाते। ठीक है, so you see in my biodata whether you observe 90 for BTech but MTech 2005 part time, full time भी नहीं, non get। ठीक है, so and I am just like hard mass का बना हुआ आपके जैसा ही हूँ, and I am what frankly or honestly telling that moment I stepped into VNIT, the circumstances made me aware। अब एक्चुअली वीएनआईटी ऐसी सिस्टम है कि मैं काम नहीं भी करूँ कुछ, सिर्फ सब्जेक्ट पढ़ाऊँ और जैसे ऑफलाइन, तो भी 1 तारीख को सैलरी मेरे को गारंटेड नहीं मिलेगी। इतना तो मानते हो, तो इतना कुछ करने की जरूरत ही नहीं, इजी लाइफ। बट ऐसा नहीं है, इट इज वेरी चैलेंजिंग। ठीक है, सो इफ आई एम गोइंग एज एन इवेल्युएटर फॉर एमबीए देन आई हैव टू सी टू इट दैट माय डिपार्टमेंट शुड नॉट गेट लेस देन 6 years। नहीं मिला तो फिर फायदा क्या, दूसरों को सब अकल से। That kind of role comes. Nowadays, teaching anywhere is not that easy job. So many committees, MBA, this, that, survival on top of it. So survival of the fittest. So on every month you have to check it out whether there is any value addition in our knowledge or not. हमको पढ़ने का ही बहुत ये लगता है, कौन पढ़ेगा कौन नहीं पढ़ेगा, ऐसा नहीं। आपकी स्किल डेवलप होगी तो आपको अपॉर्चुनिटीज भी मिलेगी। यू कैन बी एनर्जी ऑडिटर, यू कैन बी डिजाइनर, यू कैन डू कंसल्टेंसी टू पीपल, वॉट एवर, एन नंबर ऑफ थिंग्स आर पॉसिबल एंड यू कैन अर्न अ लॉट। इफ यू आर अर्निंग, यू शेयर ए डील विद द कॉलेज दैट दिस प्रॉब्लम आई विल ब्रिंग इट टू द कॉलेज। ठीक है, दिस काइंड ऑफ सर, देन यू नीड असिस्टेंस, देन यू टेल स्टूडेंट्स ओके यू कम, आई विल गिव यू द स्टाइपेंड। सारे अच्छे होशियार बच्चे आपके पास आए प्रोजेक्ट करने के, फंडिंग आया तो, and nowadays funding and all is given even to private colleges also. Only thing is the idea should be good, the fundamental should be clear, then the survival is। ठीक है, so all the best to you, and if any like quickly some couple of questions or queries are there then I can take them। Many or rather all those which are not open source, they have university editions which are student versions basically. So HFSS, CST and all of them like students can download. Only thing is I think they need roll number or some authentic email ID of the college. CST. Usually the popular are CST and HFSS. But we have all. Actually, each tool, if you find, has its own advantage or disadvantage or capability. Like CAD FICO is very good for defense project. So FICO is, हाँ, उसके सबके फ्री। देखो हमारे पास लाइसेंस वर्जन होने के बाद भी अब लाइक आई एम टीचिंग विच सब्जेक्ट वेवगाइड्स एंड एंटेना व्हिच यू कॉल इट एज एफआरएस, बिल्ड एंड रेडी। अब मुझे थोड़ी किसी ने आके बताया कि आपको ये करना है वो करना है, लेकिन वो पढ़ाते वक्त उसमें वी टेक 15 days एंटीना डिजाइन वर्कशॉप सब्जेक्ट के बीच में कंपलसरी। बिकॉज एंटीना ऐसे पढ़ा के क्या फायदा जब तक बच्चा खुद फैब्रिकेट नहीं करेगा। एंड लिटरली यू विल फाइंड दैट कॉपर वायर लेके उसको काट के फाइल से घिस के सोल्डर करके ग्राउंड प्लेन शीट में से लगा के वो मोनोपोल डाइपोल एंटेना बनाता है, बीएनसी कनेक्टर लगाता है, फिर वीएनए पे जाके चेक करता है। एक्सेसिबिलिटी इज गिवन। अब वहां हम बोलेंगे कि वीएनए बहुत महंगा है तो इसको टच मत कर, सिर्फ डेमो ले, या फिर सिर्फ दिखा दिया पावर स्लाइड पे, तो कोई मतलब ही नहीं है। तब जाके उसको समझता है कि एंटेना मैंने बाजू के स्टूडेंट के साथ बात करते करते ज्यादा फाइल कर दिया तो मेरी रेजोनेंट फ्रीक्वेंसी शिफ्ट हो गई। अब 15 मार्क का टीचर असेसमेंट है, ठीक है, वो किस चीज पे? सिंपल सिमुलेशन करो और मेजर्ड रिजल्ट करो फैब्रिकेशन के बाद। ये जितने मैच होंगे उतने 15 में से मार्क मिलेंगे, जितने नहीं मैच होंगे उतने कम मिलेंगे। सिर्फ एक ही एक्सरसाइज, करो या मरो। ठीक है, जब वो चैलेंज है तो वो भी लर्निंग कर्व के थ्रू जाएंगे, सो प्रैक्टिकल एक्सपोजर है। अब ये सब मैं इसलिए बता रहा हूँ कि 120 स्टूडेंट्स है, तो इतने तो लैब में एट ए टाइम एक्सपोजर नहीं कर सकता, लाइसेंस वर्जन है भी, तो कहाँ से आया? हम लोग फ्री ओपन सोर्स जो वो स्टूडेंट वर्जन है उनको बोलते कि डाउनलोड करो। Now that time that has a, if FEM it is doing some grid or mesh size limitation it will have कि I won't go beyond 25 or something like that। आप एक complicated design उसको दोगे जो आपके PhD का है, वो हाथ खड़े करेगा कि अभी आप खरीद के लो, ठीक है। बट बेसिक मोनोपोल डाइपोल फ्यू पैच एंटेनास और ऑल इट विल बी एबल टू डू। अब आपने को नए से अगर सीखना है तो शुरू में थोड़ी ना अपन एकदम 7 लेयर माइक्रोवेव कंपोनेंट डिजाइन के लिए जाएंगे फ्रैक्टल बेस और पहले धीरे 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 शुरू हो। तो दिस काइंड ऑफ एलिमेंट्स यू हैव टू ब्रिंग इनटू दिस। तो ओपन सोर्स बहुत सारे अवेलेबल, you can make a search. Generally IE3D, HFSS, CST, CAD, FICO, these are the tools which are very popular. Okay, this is it. Anything else? Huh? Material selection is the epsilon, basically what your purpose is. As I have said, FSS जब आता है तो whether you want absorber or whether you want a reflector, based on it will be there. Most like 90% time people go for FR code और फिर थीसिस में लिखते हैं कि मैंने इसका कन्फॉर्मल एरे बनाया। वही मेरा चैलेंज रहता है कि वो मुड़ता ही नहीं है, तूने बनाया कैसे? इफ यू ट्राई टू डू बेंड इट इट विल ब्रेक, ठीक है। एंड देन ऑलमोस्ट द थीसिस इज अप टू द लेवल ऑफ रिजेक्शन, बिकॉज अगर आपका फाइनल एम कन्फॉर्मल एरे बनाना था तो मेरा नेक्स्ट क्वेश्चन है बेंडिंग एनालिसिस कहाँ है? सिमुलेशन में क्योंकि जो प्लेन है उसको मैं थोड़ा भी बेंड कर दूं, दोनों एंड वार्पिंग अगर होगा उसके पूरे इलेक्ट्रॉनिक कैरेक्टरिस्टिक्स चेंज हो जाते, ठीक है। और वो प्लेन के सरफेस पे लगा है तो डायरेक्शन और ऑफ अराइवल का गेम है ना पूरा। मतलब उसने उल्टा किया तो अपना रडार छोड़ दिया और एनिमी का रडार पकड़ना शुरू किया, तो जहां स्टेज वर्क करना चाहिए उसके बिल्कुल उल्टा हो। तो कौन से एंगल ऑफ इंसिडेंस के लिए वो सिग्नल को रिस्पॉन्ड कर रहा है, ठीक है। तो 0, 20, 30, 90 आया तो दैट बेंडिंग एनालिसिस इज टू बी डन, ठीक है। उसको एक नॉन रिफ्लेक्टिंग आइडियल इलेक्ट्रॉनिक सरफेस से बेंचमार्क करना पड़ता है। ये सब कब पता चलता है? हमको भी नहीं पता चलता, बट जब आप पेपर पढ़ते हो तो मोस्ट ऑफ द टाइम आई हैव सीन, अगर पुअर थीसिस वो है जिसके रेफरेंस में मैक्सिमम पेपर कॉन्फ्रेंसेस के, because conference papers do not have any authenticity. The reviews are not that stringent. Few only scheduled conferences have. But जिस थीसिस में ट्रांजैक्शन पेपर्स को ही पढ़ के रिव्यू बनाया गया है वहां समझ में आ जाता है कि बिकॉज जब मैं 3-4 पेपर पढ़ूंगा और फिर मेरे को ध्यान में आएगा बेंडिंग एनालिसिस इसने भी किया, इसने भी किया, इसने भी किया। अब इन 3 पेपर का रेफरेंस देके मैं अपना पेपर छापूंगा तो वो रिव्यूअर मेरे को पहला क्वेश्चन ही पूछेगा तेरा बेंडिंग एनालिसिस कहाँ है, ठीक है। हाँ, माय पेपर वुड नॉट स्टैंड देयर, देन आई हैव टू गो फॉर। तो ये नॉलेज जो है वो प्रॉपर लिटरेचर रिव्यू इज द बिगेस्ट थिंग इन एनी रिसर्च। आपको हर थोड़े दिनों के बाद पढ़ते रहना, ठीक है। अगर ऐसा नहीं रहता तो वाई डॉक्टर्स वुड नीड एमआर, मेडिकल रिप्रेजेंटेटिव की जरूरत ही क्या है? उन्होंने तो डिग्री के बाद सब पढ़ लिया था, कौन सा मेडिसिन है क्या है, एवरीथिंग दे नो, व्हिच कंपाउंड एंड व्हिच मिक्सचर है। बट टू अपडेट एंड एजुकेट डॉक्टर्स इज द चैलेंजिंग जॉब ऑफ द मेडिकल रिप्रेजेंटेटिव। यू नो things have changed now, you have to change your mixture or this thing or drug combination, it has reactions, no reactions or whatever, or no reactions drug have come, ठीक है, ऐसा बहुत होता था पहले। मलेरिया की गोली आती थी, ये खाएगी धड़ाधड़ उल्टियाँ चालू। अभी आती है तो कहाँ खाई पता नहीं चलता। अर्लियर एंटीबायोटिक्स जो थे, अभी भी है बहुत सारे एंटीबायोटिक्स जो स्टमक अपसेट करते हैं। यू हैव टू लोड एंटासिड विद दिस। अब कुछ आए जो इनरेंट एंटासिड बेस्ड। सो दे आर डूइंग R&D ना, पेशेंट को रिलीफ देने के लिए दे आर डूइंग। डॉक्टर को पता ही नहीं रहेगा कि ऐसी गोली बाजार में आई है, तो वो कैसे बताए। ठीक है, अब MR तो कंपनी के हैं, ये भी हो सकता है कि उसके बुरे इफेक्ट हो तो उन्होंने मार्केटिंग कर दिया। तो डॉक्टर को भी तो अकल चाहिए कि उसको देने से पहले 4 बार जर्नल पढ़ के उसको मेडिकल काउंसिल में डिस्कस करके फिर प्रिस्क्राइब करें। नहीं तो होता है ना, अभी जैसा हुआ कौन सा कफ सिरप और ये वो लाइक। That's why I always tell students कि we are fortunate that you are not in medical। नहीं तो कल पेशेंट आता, क्या हो रहा है सर, दुख रहा है, ये यूनिट मैंने पढ़ा ही नहीं था, बिकॉज यूनिटाइज सिलेबस है, सो वी हैव स्किप। ठीक है, तो ऐसा नहीं होगा। So anyway, like I have already told you that any this thing collaboration or you are designing, then you are most welcome to the department. So thank you, considering that no further queries are there. So taking benefit of doubt that either you have understood nothing or understood everything, so I will take the second chance. Okay. Thank you. Yes. ऐसा कहाँ लिखा है कि ऐसा नहीं कर सकते? ऐसा जब बहुत बार क्या होता है, हम वही रेफर करते हैं जो लिखा है। ठीक है, जहाँ नहीं लिखा है कि ऐसा नहीं करना, मतलब वो आप कर सकते हैं। ऐसा इंटरफेरेंस तो आप फिल्टिना फिल्टिना लगाओ तो भी आएगा, विल डिपेंड ऑन द एप्लीकेशन। So I think you have organized one lecture by Dr. Arvind Kumar, if I'm not wrong, in the schedule. So you can ask this question specifically to him. He would be rather expert of that field, so he has many papers in that. Thank you.
Thank you so much, sir, for taking us through all the designs and challenges, issues with the antenna design specifically, and helping us with the case studies which are already there, and motivating the participants to go into this field more deeply. I want to mention the participants that we do have HFSS and AWR in our labs, so we will be going through all those hands-on sessions with those softwares also. Currently, we have the sessions going on with various topics as defined, and in the second half, maybe 2:30 onwards or maybe 4 onwards, we'll be having the hands-on session for those software. I request all the participants now to proceed for lunch in the back. All the participants are requested to proceed for lunch in the mess. After that, you are required to assemble in CC lab, Computer Center lab, which is in A wing. We will start the next session by 2:15 p.m. sharp. Thank you, sir.
Thank you.